Ever wondered why planets have different colors? Why Mars is red, Earth is blue, and Jupiter is a mix of orange and white? These questions may have sparked your curiosity as you gazed at images of our enchanting solar system. The answer lies in a blend of intriguing factors, each contributing to the unique hues we see. Atmospheric composition plays a crucial role. The gases that envelop a planet interact with sunlight in a myriad of ways, creating spectacular color displays. Then we have the surface materials: rocks, ice, dust. Their composition and texture also influence a planet's color palette. And let's not forget the interaction with sunlight. The way a planet's atmosphere and surface absorb, reflect, and scatter sunlight is a significant factor in defining its color. From the rosy red of Mars to the serene blue of Earth, each planet tells its own colorful tale. So, stay tuned as we delve into the fascinating world of planetary colors. Mars, famously known as the red planet, but do you know why? This celestial body, fourth in line from the Sun, has a rather distinct hue that sets it apart from the other planets in our solar system. A rusty reddish color tints the Martian surface, making it appear as a bright, fiery star to the naked eye. But the red isn't just a part of Mars's aesthetic appeal. It tells a story of the planet's geology and history. This distinctive coloration is due to the abundance of iron oxide, or as we commonly know it, rust on its surface. Yes, you heard it right. Mars is essentially a giant, rusty sphere floating in space. But how did this come to be, and how did we confirm it? The answer lies in the Martian soil and rocks. Billions of years ago, the iron-rich rocks on Mars came into contact with oxygen, resulting in a chemical reaction that created iron oxide. This process, known as oxidation, is the same that happens here on Earth when iron is exposed to air or water. Over time, the iron oxide particles got dispersed in the Martian dust, painting the entire planet red. But wait, how can we be sure that it's really rust that gives Mars its red color? Well, we have the numerous space missions to thank for that. Probes like the Mars rovers, which have been exploring the Martian surface for years, have sent back data confirming the presence of iron oxide. They've even taken close-up pictures of the rust-colored rocks and soil, leaving no room for doubt. But Mars' color isn't just a spectacle for us to admire. It also provides valuable insights into the planet's past. The prevalence of iron oxide suggests that Mars once had a more Earth-like environment, with liquid water and a thicker atmosphere, conditions necessary for the formation of rust. And so, our celestial neighbor Mars, with its rustic charm, stands as a testament to the immense power of natural elements and the passage of time. Its color is not merely a visual trait, but a key to unlocking the secrets of its past and understanding its present. So Mars owes its iconic red color to its rusty surface. Our home, Earth, a beautiful blue marble. But what gives it this unique color? Our planet, Earth, is often referred to as the blue marble due to its distinctive blue appearance when viewed from space. But ever wondered why Earth appears blue and not some other color? Well, the answer lies in the interaction of sunlight with Earth's atmosphere and oceans. Sunlight, also known as white light, is a spectrum of many different colors, each with a different wavelength. When sunlight reaches our planet, it interacts with the molecules in Earth's atmosphere. This interaction is known as scattering, but not all colors scatter the same. The colors at the shorter wavelength end of the spectrum, blues and violets, scatter more than colors with longer wavelengths, like reds and yellows. This phenomenon is called Rayleigh scattering, named after the British physicist Lord Rayleigh, who first studied it in depth. So, when sunlight hits the Earth's atmosphere, the shorter wavelength blue and violet light is scattered in all directions, giving the sky its blue appearance. But wait, if violet light scatters even more than blue, shouldn't the sky appear violet to us? Well, our eyes are more sensitive to blue light and less sensitive to violet. Plus, sunlight reaches us with less violet to begin with. Now, let's add the oceans into the mix. About 71% of the Earth's surface is covered by water. Water absorbs colors in the red part of the light spectrum more than colors in the blue part of the spectrum. When sunlight hits the ocean, the water appears blue because the blue light is reflected back to our eyes. So it's the combination of Rayleigh scattering by Earth's atmosphere and the absorption and reflection of light by Earth's oceans that gives our planet its unique blue appearance. So Earth appears blue due to the scattering of sunlight by the atmosphere and the presence of vast oceans. It's a fascinating display of physics and chemistry that results in the beautiful blue marble we call home. Jupiter and Saturn, the gas giants, have a mesmerizing mix of colors. Ever wondered why? Let's journey into the fascinating world of these celestial bodies and their brilliant hues. The first stop in our cosmic tour is Jupiter, the largest planet in our solar system. Jupiter's iconic swirling bands of white, orange, and brown are due to the various gases and elements present in its colossal atmosphere. The white clouds that you see are actually ammonia crystals, which reflect sunlight and give Jupiter its distinctive white streaks. But what about the orange and brown shades? These colors are the result of compounds called chromophores, which are produced when ultraviolet light from the sun interacts with ammonia and other elements in Jupiter's atmosphere. These chromophores absorb certain wavelengths of light and reflect others, hence the beautiful blend of colors we see. Next, we'll voyage to Saturn, the second largest planet in our system and another gas giant. Saturn is known for its stunning rings, but it also has an intriguing color story. Its overall yellow hue is due to ammonia crystals present in its upper atmosphere. These crystals scatter sunlight in such a way that we perceive Saturn as yellowish from our viewpoint. However, the story doesn't end there. Saturn's atmosphere also contains traces of other elements, including phosphine and hydrocarbons. These compounds contribute to the planet's subtle shades of gold and orange, adding to its overall yellow appearance. It's also worth noting that both Jupiter and Saturn are dynamic worlds, with storms and winds influencing their atmospheric compositions and consequently their colors. The famous Great Red Spot on Jupiter, for instance, is a massive storm that's been raging for centuries, lending a striking red hue to a portion of the planet. So the colors of Jupiter and Saturn are due to the presence of various gases and elements in their atmospheres. It's a cosmic dance of sunlight, gases, and elements that results in the mesmerizing colors we see, painting a vibrant portrait of our solar system's gas giants. Uranus and Neptune, the ice giants, are known for their beautiful blue color. But what causes this? Let's delve into the science behind it. These two distant planets, Uranus and Neptune, are often referred to as the ice giants of our solar system. Unlike their gas giant siblings, Jupiter and Saturn, they carry a significant amount of ices. Now, don't be fooled by the term ices. Here, it doesn't just mean water ice, but also ammonia and methane, substances that freeze at incredibly low temperatures. Now, you might be wondering, what does this have to do with the blue color of Uranus and Neptune? Well, it's the methane in their atmospheres that plays a key role in giving these planets their distinctive hue. Methane is a colorless gas, but it has an interesting property. It absorbs red light and reflects blue light. When sunlight, which contains all colors of light, reaches Uranus and Neptune, the methane in their atmospheres absorbs the red portion of the spectrum and reflects the blue. This reflected blue light is what we see when we look at these planets from Earth or through the lens of a passing spacecraft. It's worth noting that both planets have similar atmospheric compositions, hence their similar coloration. However, Neptune appears a more vivid blue, while Uranus exhibits a more muted cyan hue. This difference is thought to be due to the presence of an unknown component in Neptune's atmosphere that gives it a richer color. It's amazing, isn't it? These planets aren't blue because they're covered in oceans or because they're sad. Instead, it's the unique chemistry of their atmospheres that determines their color. In the grand tapestry of our solar system, each planet has its own unique color, reflecting its individual characteristics and composition. The beautiful blue hues of Uranus and Neptune are a testament to the diverse and colorful nature of our cosmic neighborhood. So, the blue color of Uranus and Neptune is due to the presence of methane in their atmospheres. And there you have it, the mystery behind the blue color of the ice giants, unraveled. We've journeyed through our solar system, exploring the colors of different planets. Let's summarize what we've learned. We started our voyage with Mars, the red planet. Its signature color doesn't come from its atmosphere, but rather from the iron oxide, or rust, on its surface. This rust scatters the sunlight in a way that gives Mars its distinctive red hue. Then we made our way to our home, Earth, the blue marble. The blue color we see when we look at our planet from space is the result of a process called Rayleigh scattering. This process scatters the shorter wavelengths of light, like blue and violet, to the sides, creating a blue sky. But why don't we see a violet Earth instead? The answer lies in our eyes, which are more sensitive to blue light, and because sunlight reaches us with less violet light. Next, we ventured to the gas giants Jupiter and Saturn. These planets are primarily made of hydrogen and helium, just like stars. But it's the trace amounts of other elements that give them their colors. Jupiter's banded appearance comes from ammonia crystals in the atmosphere, while Saturn's golden color is the result of a top layer of ammonia clouds. We then traveled to the ice giants, Uranus and Neptune. Their blue color is due to the absorption of red light by methane in their atmospheres, reflecting back out the blue light that we see. In essence, each planet's color is a story of its composition, its atmosphere, and the way it interacts with sunlight. Each is a unique tale, revealing insights about what lies beneath and above their surfaces. We've learned these stories through years of observation, research, and countless spacecraft missions. Next time you look up at the night sky, remember, the colors you see tell a story about what lies beneath and above a planet's surface. The colors of planets are more than just beautiful sights. They're keys to understanding the composition and history of these celestial bodies. As we've journeyed through our solar system today, we've seen a spectrum of colors, each one telling a unique story about its planet. But remember, our journey doesn't stop here. In the vast expanse of space, there are countless more celestial bodies, each with their own intriguing colors and mysteries to uncover. So let's keep exploring, keep questioning. In our upcoming videos, we'll delve deeper into the mysteries of our universe. We'll explore topics like the formation of galaxies, the fascinating world of black holes, and the possibility of life beyond Earth. So stay with us as we continue to unravel the secrets of the cosmos. And as you gaze at the night sky, remember that every color you see is part of a grand cosmic story. Keep looking up, keep wondering, and remember, the universe is full of color and mystery waiting to be explored. Before we wrap up, we'd like to hear from you. If you learned something new from this video, then please give it a like and share your thoughts in the comment section. Did you know about these planet colors before? Or did any facts surprise you? We'd love to know. Don't forget to subscribe to our channel for more such enlightening content. Let's spread the knowledge and the wonder. Share this video with your friends, family, and anyone you think might enjoy a colorful journey through the cosmos. Your engagement helps us to continue creating and sharing more fascinating insights about our universe. Remember, every view, like, share, and comment contributes to the exploration and understanding of our amazing cosmos. Thank you for watching, and thank you for being a part of our community of curious minds.